Let us not waste time and move to network architecture. That is a very simple explanation over here. So see, sometimes in my notes, I generate notes with the help of a very powerful AI. You can see in the browser, in the screen recording. I'll make a video very soon about that by promoting the app, which helped me make very useful notes. It reads an entire textbook and gives me small precise good explanations. You can see here in the early videos, you can see the notes which I used to make on each topic used to be like 10 pages, 30, 40, 50 pages, 60 pages. But now here with the help of this, I am including all the diagrams and making notes. I'll be promoting that later and explaining how useful it is. You can see over here it's a very useful and helpful AI powered tool. We'll see that. So here we have network architecture. What is network architecture? It is like how neurons are arranged and how the signal is flown. It will be showing all over that how they are arranged and connected. See, interconnector also, you can see the connector or interconnector architecture is closely linked to the learning algorithm used to train it. So here we have three main classes of architecture. You have, see, a single layer, you have multi-layer, then recurrent neural network, then also a hidden thing in that. So in the single, you have only the input layer source and output layer source. So see, they just each input is for pointing towards one output layer. So see, one input all goes on all four directions. There is no loops over here. So single layer refers to output layer only. Input layer not counted because no computation. When useful, when is this useful? Simple problems, linear or near to linear mapping, easy and fast. Then you have multi-layer feed forward network. So in this, what you have introduction to one. See, one hidden layer is introduced here. Input, each and every input will be associated towards this hidden layer, and then this hidden layer will be connected to all the output layers. Here has one or more hidden layers. See, either one or more. See, in this case we have four. Hidden units are not directly visible from input to output. So see, when you talk about direct in the hidden layers is for what to say, for the computer, inside the computer. For human eyes, whatever we process, for chat gpt, we'll type something, we'll get the output. So input output, what's happening in the background, very distinct, it won't show all those actual things. Then hidden layers help extract higher order statistics and complex features. Keyword C, you have to talk about hidden layer, hidden neurons, fully connected. Every node connects to every node in the next layer. So in the sense what, every node in the first layer is connected to every node in the next layer. In the sense, each input is connected to every hidden node. Then each hidden node or hidden neuron is connected to the next layer, that is output layer. Partially connected, some links missing, so it can be partial, but in this case you don't have any partial connection. In the sense what, this will lead to only one output, not to this output, or here this input will be pointing to all feed all hidden layers, but not this one. It's just like that. Then naming example, so a network line input hidden output is written as MHQ. So example 10 for 2. Okay, so 10 here input layer for hidden layer and 2 output layer. So here's this 10 for 2, same thing. Then you have recurrent neural network. So recurrent neural network will usually have a feedback in processing. So see, Z inverse unit time delay operators, we saw that B thing. Yeah, then W is what, A, and B is what, Z inverse. If you have not seen this, you have to see the feedback video. It's very small, you'll understand everything very fast. What it is, a recurrent network has at least one feedback loop, at least one. So here, how many do we have? You see here, it's, see, 1 2 3 4 5 6 7 8. So here we are having like 1 2 3 4. So we have four feedback loops and all. So basically each blue line is a like type of feedback type of thing going back. So see here, feedback loop, unit time delay operator, non-linear dynamic. When neurons are non-linear, may have no hidden neurons or with hidden neurons. So there is two diagrams in which, see here, hidden neurons are there, here hidden neurons are not there. Okay, so feedback is there. So whatever output you are getting, see, two outputs were there. Okay, from this two outputs, see, one feedback is going. Yes, yes, from output you have two loops going back. See, you understood, right? And then from, instead of output path, see, directly from hidden node you are having to feedback, and it's just like that. So self feedback loop, neuron output fed back to its own input, may or may not. See, this is self feedback. Okay, why important? Feedback gives a network memory. It depends on past, so it's useful for sequence time based tasks. So whatever happened in the past, so for example, I did something, Like I gave the example of that massage thing. So pain was it. So that is the experience. Now it's in the past. If the feedback is given to me, be careful on the thing. So I know about the past where it was. So I'll make sure I don't, press at the same point. So here you have the comparison table. See, is there any loops, single layer, multi layer? No, but in recurrent, yes, we have. It can be one or more. There can be a self, loop also. Key features, simple for mapping, hidden layers, learn complex feature, memory plus dynamic, unit time delay. Okay, typical use basic classification, regression, XOR like complex pattern, sequence and time signals. Oh, see, that's all you have to know about network architecture. You can see over here in the textbook as well. Much is not there, and it completes. So we'll let us see how much I have completed. If I go to the this part, so I can easily mark we have completed the actual important topics, and then we can happily move to second module. I won't be explaining this just yet. We'll see if we have enough time, we'll cover the everything. Okay.